start the recording here for usual case. Okay, then let me briefly start today's interview. Today we are gonna talk about Miguel Morales, and he's a full-time deep reinforcement learning researcher on the Lockheed Martin. By the way, I'm just checking from this on the web, so if there's something like outdated or wrong, you can just tell while I talk about it. And he's also a part-time instruction associate at the Georgia Institute of Technology, and he also did, as far as I know, he did also work for the Udacity at some content creation, and he is also the author of the Grokking Deep Reinforcement Learning Book. And today our conversation will be about mostly questions and answering some of the questions that we already prepared. And you can also ask any questions on the chat that we will try to ask. And let me start welcoming you to our interview. Thank you for accepting this. It's been,
Yeah, thank you, Ken. My pleasure, and Ramesha. Nice to meet you guys.
By the way, our channel is we just founded our channel last year. We're just a local community, I would say. We are doing some local projects here, like with the new technologies and simulations, try to do mostly remote work, I would say. And if we can also find time, we are also trying to interview like prominent researchers on the reinforcement learning, robotics. Sometimes it's kind of who can be found at times. And let me start with the one question. But that's kind of philosophical, I would say, and that's it. Like, how would you define what is the like intelligence for you? That seems like a good starting question and for the tension.
Yeah, that's a really good question because it's controversial in nature. What's intelligence, right? Is it human intelligence, or is it animal intelligence, or is it insect intelligence? Like, what level of mammal or insect, right? What level of intelligence are we talking about here? And for the sake of artificial intelligence, I personally do not care whether the thing that you're developing has religion or culture or dreams or whatever. That's really not relevant. I think there is a quote that is very interesting. It's like whether a submarine can swim or not, or no, whether a computer is intelligent or not is equivalent to whether a submarine can swim or not. It doesn't really matter, right? So if it can swim just like a whale does, or it can just navigate through underwater, it does the job, right? So in my view is much more practical. Is, can I outperform the current baseline, right? Can I do better? Can I create a computer program that through some medium, and that could be through learning, right? Machine learning, artificial intelligence, reinforcement learning, deep learning, all this kind of stuff. It doesn't really matter. Those are tools in the toolbox, right? As long as you can outperform the current baseline, then to me that's showing intelligence, right? Yeah. And especially if that baseline is a human, then even more so, right? It's even more impressive. We can think about AlphaGo, right? AlphaGo beat this world champion. Now, AlphaGo doesn't have dreams or desires, or doesn't feel pain, or that doesn't really matter. We're not trying to replicate human. We're trying to outperform a human in a particular task. Yeah. And as long as that is in there, then to me that's intelligence.
Yeah, that I agree. I would agree. A lot of times people or researchers trying to basically replicate what is like human without actually thinking like if it makes sense to replicate exact.
That's the point, right?
Yeah, that I would agree. And maybe now we can just deep a little bit about yourself and your career. And I think you, from what I gathered, you worked actually a lot of companies before you actually what you are doing at the moment. So, like, can you tell me about a little bit about your career and how did your interest in AI, robotics, or machine learning actually started? maybe briefly talk about it.
Yeah, absolutely. So, I've always been interested in artificial intelligence. Although I thought about when I was a kid, I thought about it as robots, right? So like a robot looking, or I'm sorry, human looking robot, right? So that to me was artificial intelligence when I was a kid. But I always had it in my mind, like that's actually something really cool. I was born in South America, Venezuela.
Yeah.
And I studied there, and I lived there for probably 18 years, 20 years approximately, right? But then, political situations over there, all over the world, but there in particular was very difficult. So I moved to the United States, and then I started, well, first, I had to work to kind of, pay my stuff, right?
Yeah.
But then at the same time, simultaneously, I thought about, well, why not, pursue that dream? Because, you know, it happens that sometimes in those countries, like in South America, like you graduate as an engineer, but then you're like driving a taxi and really not doing your profession. It pays more to do other things than to be a professional in some sense, right? But once I'm here in the United States, it's pretty obvious that is an opportunity that opens up, right? But I had to balance two things. So I first finished my bachelor's while I was working some, low skill jobs. Then I got I would say my first, software engineering job at AT&T, doing some set-top boxes and like TV stuff. Not really in love with the mission behind that, because I don't care if, I don't care if you guys watch more TV or not. That's really not important to me. But you have to do what you have to do. So I went from there to another job at Cisco and other places, and great people and whatnot. But I always had in the back of my mind that I wanted to get back to study that. I mean, it's just very interesting. And then the opportunity came with the online masters of science and computer science by Georgia Tech, which anybody in the world can take that program. And it was phenomenal. I mean, I think that the risk they took by allowing people from just massively delivering this education or providing this education, that was a huge risk for a top 10 university. Okay, I mean, I don't know how they did it, to be honest with you. I would not do it. If you're top 10, you're not going to get into that risk, but they did. They play that, and I think it was phenomenal. So it changed my life completely. I mean, I'll be honest with you, that program is the inflection point. I not only started meeting people, I studied with Charles Isbell, now the dean of the College of Computing. I studied with Michael Littman, was teaching the course that semester, Professor Littman, Brown University, one of the big names in reinforcement learning. And when I found reinforcement learning, their reinforcement learning course, actually not too long ago, 2015, I fell in love. That was phenomenal. So after that, I had opportunities to I got with Udacity, the contents. That's 3-4 years after I did my course, but I stayed TAing the course every semester and trying to improve the course and so on. And so I would say that is how I enter the field. And actually an announcement, I don't think many people know, but I'm actually going back and doing a PhD with Charles Isbell as my advisor. I'm actually going to start in fall this year, so that's new, brand new.
Congratulations! I think that's a great thing to hear. I would agree. The online masters stuff, I think now it's more than ever. There's a lot of even the Udacity and some other universities kind of started offering these type of educational online based background, and I think it's a really good opportunity. And if you a situation like you come from another country or something like this, that it gives you a way to kind of also work, and while at the same time gain some money to pay for the educational background. It is, I think, very useful. And I think after seeing successful candidates like you, they probably continue on these programs like this, and I think it's a great benefit, and it's a really
I think it's a life-changing the opportunity and the program. So they did a great job, and Also, I would say that anybody really who wants to get into it, it's out there, guys. I mean, it's just a matter of deciding and committing, right? And just working nonstop, day and night, to get better, to build things, to also share yourself, right? So sure, I wrote a book, right? But really, I mean, there's lots of things that can be done. And not because there's one book, you cannot write another book, right? There's always a perspective that folks can appreciate, right? A different perspective.
I agree, completely agree. And your life story is very interesting and fascinating at the same time, and very successful one. I also hope your PhD will go very well, like your masters. And yeah, Rumeysa, you want to ask the question? Or yeah.
Yes, of course. Hello, first of all. Do you
Hi.
think that are we on the way to the artificial general intelligence? So, I mean, do you see reinforcement learning as a path to artificial general intelligence? So, people always ask these questions.
Yeah, absolutely. And I do think so. I like reinforcement learning in particular, not just the kind of basic reinforcement learning. Basic reinforcement learning is great, but the idea that there is some reward, I'm not sure about that 100%, right? So there has to be something else, right? So I know that so reinforcement learning has it right in the sense that we learn by trial and error. Okay, so we as humans, and by that I mean entities that are the well, I would say the smartest, yes, in the universe so far. Well, not sure in the universe, but anyway, so we're one of the top, right? And I would say that then the idea of trial and error learning is a good one. Now, the part that where I don't know is the reward function, right? Where does the reward come from? And this is something that I think even Rich Sutton, said, well, but the agent. So it doesn't matter. It has to be outside of the agent, whatnot. So sure, but I don't know. I don't receive a reward when I when I eat food. I do feel the pleasure, right? But I think the pleasure comes from something different, because I can. I like, for instance, this kind of food, and maybe you don't like that kind of food.
Yes,
so the food doesn't give you the reward. You have the reward internally somewhere. And then, so I think that there is a, there needs to be more research in that area, that portion, right? Where does that reward signal come from? But other than that, I think the idea of reinforcement learning, and I would say with deep learning, yes, that probably equates to artificial intelligence. And probably some of the best results. I think unsupervised learning has to play a big role, and that's where I think perhaps the reward function can be, can come from.
Yes, you're right.
Yeah.
Thank you.
Yeah, absolutely.
In the topic of the reinforcement learning, I think we maybe also want to learn a bit about like your perspective on the deep reinforcement learning. I think the deep reinforcement learning is a really fascinating topic. I'm also kind of separating from the like classical reinforcement learning that was also applied in the 90s, since the 90s, I think, maybe, or earlier. But in the topic of the deep reinforcement learning, or the reinforcement learning in general, what does it actually means to you? I mean, like, besides like the artificial general intelligence, like what are like what do you think, like, as a practical use cases, or is it just something that like the computer science researchers use to like do some cool stuff, but in the end is it pointless, or does it make sense to use RL or yeah, what is your perspective on this?
Yeah, so well, I would say that, well, no, is not just creating cool things that you demonstrate. I have a job and I do that kind of stuff, right? And then I'm sure that there are other people that do that kind of stuff, and sure, because I cannot talk about my work because of the issues obviously there, right? But you can see results. Actually, some of the results by Lockheed Martin are public. If you look at Alpha Dogfight, search it online, you can see how aircraft, in dogfighting, can be, well, in that case, we outperform a human pilot, trained human pilot, right? But okay, so we had some advantages, right? So we were able to see the full, variable, the full, the observation space was fully observable. So we were able to see all of the variables, the location of the aircraft and things like that, right? So okay, right, that's not a complete story, right? So but I would say that deep reinforcement learning, and I would say more, I understand folks wanting to get to artificial general intelligence. However, I don't see the practical use for that today. Something to actually having today. I don't know, general as in what exactly? As in that the intelligence can fly an aircraft and at the same can go shopping and can also wash dishes. That kind of general intelligence. Well, I don't care about a robot that can do that. You understand? And I don't think we should care about that. I think that's why we're humans, right? But I think the optimizing some of the things that humans do, that's a more interesting goal for me for deep reinforcement learning. And I think it's pretty good at that, right? So you have a very specific task.
Yeah.
You can define it well. You win if you have a game of chess, right? You know when you win, when you lose. You can then use that to teach that particular task, that signal. You can represent it as a reward function, and then train your deep reinforcement learning agent to do the things, right? I do understand the need or the want for artificial general intelligence, but at the same time, sometimes those things actually are not useful because it gets in your way. Like, you want to think about that, and then it's just such a hard problem to solve that I think we need to concentrate. Is like, how do you eat an elephant? Well, one piece at a time, right? So the same thing. It's like artificial general intelligence. How do you solve that problem? I don't know. Why don't we talk about sample efficiency and reinforcement learning, right? Yeah. And then you solve those little problems, and then at one point you're going to have the big picture. So long-term, artificial general intelligence is a good thing. It's a good driver too, to get you going. But once you start working on things, I think that you have to always bring it back down to simple problems and tasks, and then implement those things. One bite at a time, I guess.
Yeah, I agree also. I think a artificial general intelligence just acts like a motivator for people to work on this stuff.
And it's excellent for that, by the way. Yeah. I do use it a lot too.
Yeah, I agree. And like you mentioned, I think the part of the engineering should be always trying to optimize things that humans do or actually do but don't want to do, like not like repetitive tasks and things like this. And with the reinforcement learning and with recent years applied to the real world systems, we kind of start seeing things like this in actual production, not like just some test cases or benchmarks. And in the top of this, and I have actually a good question regarding to beginning of how to educate yourself in the reinforcement learning. Should we for some a student who is watching this at the moment, what should be the background to get in this? I know the static analysis is a big part of this mathematical reading and writing capabilities, also programming tasks, like the software engineering skills. What should be the appropriate way to start a career in the deep reinforcement learning or AI, maybe also in general?
I would say, so that's a really good question. I would say first, you have to have motivation, right? Willpower, because nothing drives you. You can have mathematics background, statistical, programming, whatever, but you have to have the motivation, the willpower to work through the problems, right? So reinforcement learning is pretty challenging, I would say. And then sometimes you implement an algorithm and then it works for the wrong reasons. And then sometimes it doesn't work. and it should be working. You just have to tune a single hyperparameter. I mean, it's so complicated, right? That if you don't have that determination and you say, I'm gonna have this algorithm working, period, it doesn't matter how long it takes me, then you're probably gonna give up pretty quickly, at least in that particular project, right?
Yeah.
And then the second portion to that, I would say, is try to find a problem, right? I think that's really like even if your desire is to learn and to get really good at something, put a task in front of you, right? So you put a project. I'm gonna write 10 blog posts, right? Or I'm gonna do like YouTube videos and tutorials.
Yeah.
I'm gonna these kinds of projects. You put that into your head, and then you work towards that, and then the working towards that is what's going to give you the knowledge that you want. But if you try to search for the knowledge just because of the knowledge, it's just not going to work. It doesn't work well. I think I use the analogy of working out or trying to get fit, whatnot. You have to eat well, which is information that you put into your brain, and you have to also exercise, right? So you have to practice, put your hands into the keyboard, and then try to solve a problem. If you don't do the two, I mean, sure, you can lose weight, but you're not going to look good. You're not going to look fit. And if you work out and then eat like a monkey, then you're going to be fat and ugly and whatever.
Yeah.
Right? Does that make sense? So that is kind of like the straightforward way of putting it, right? You need the two, and you need to balance it. You need to know what you're doing, right? Yeah. If you read every single blog post in the internet, you're going to be obese in your brain, right? You need to be a little bit more agile, fast, right? So try to select what you're going to read and don't read the rest. You need to be able to say, no, I'm not reading this. Now that we have so much information online, right? It's like everything. I want to learn from everybody. Well, not quite. I promise you, I've seen posts in Medium, right, that are wrong, that are just really misleading. I've seen books. I actually purchased some books to see what other people are doing, and some of them are totally wrong. It hurts me a little bit, because it's like, how could you be misleading other folks? Just don't do this, right? So I would say be very careful with what kind of food for the mind, right, you select, and then also then work and practice a lot, right? Have those two things. So that is the sort of soft skills, right? Soft in some sense. And I would say I can talk about a little bit the hard skills. I would say programming is an important thing. I would say that well, what I do is research engineering, right? As opposed to a research scientist. And programming is kind of, it's key to what I do. And I mean programming for the two sides. You need programming. You need to know how the algorithms work and learn how to code those algorithms. And then something that I mentioned in my book, and I didn't have time to actually work on, for instance, if anybody wants to learn a bunch, that's an area that needs to be covered. Nobody has really covered this area well, which is creating environments, okay? Which I think is super important, because lots of the algorithms today can work as long as you have a good environment for your particular problem. So if you care about, the stock market, you can create an environment that has that, so that you can hook up either a PPO or a DQN or any other algorithm, right? And then you can also fine tune the algorithm and kind of, research in that area. But the two sides, I think, are very important. And the environment side is not, I don't think it's well covered, because lots of folks just go OpenAI Gym and then start using OpenAI Gym, which is great, by the way. It's a great tool. But first of all, it's in the simulation, right? So maybe we should start, thinking about that outside of the simulation. And folks can actually create an interface for that. Now obviously, real time versus simulation time, which you can have many frames or seconds in a real second. Then then you have the difference. But then topics such as transfer learning come up, right? So maybe I train in the simulation and then move that to the real world. So those kinds of things. I think that there's so many things to do, really, that everybody is not just welcome, but everybody has a spot. They just have to get to work and pick your little spot and then start working towards that. Yeah. Because is so new, is so ready for contributions.
Exactly.
Everybody that is listening to this podcast, or I guess this video, But everybody who's listening has a chance. You just have to get started.
Exactly. I think some of the companies actually doing some really great work on these topics. Like I will probably mention Unity is doing some amazing work on the. There's a package they released back in a few years ago, like ML agents, and there you can easily create some environments that you imagine in a situation that you should train your RL algorithm. Like you mentioned, like most of the folks just try with simple already existing algorithms, while I think it's really good idea for benchmarking and comparing new algorithms with existing ones. I think it's also a bit useful to create in some different environments. I think it also motivates other people to kind of look about these areas, because I mean you can't simply convince people with your I don't know, the open AI some basic environments there. You can say like this is
Carpool,
the future. Yeah, I will go
Carpool.
Say, yeah.
Look, I bounced the pole.
Yeah.
Like what?
I mean, yeah, it's really a bit hard to demonstrate some of that stuff. And I think also NVIDIA is doing a bit work there with their simulations and their stack of software for the deep learning and reinforcement learning. I think that I should probably mention about, and that was a really great answer about this. And maybe I should also talk about a little bit about your book, and it's really fascinating about like how this idea came through you, and what were the challenges of writing such a book. I think it's a really hard task, and it's a really hard task even for the people who work on this stuff for many years, and it must be much harder even for you, I think. Can you tell me a bit about your book and how this process came?
Yeah, so I started, so I've been since 2015, that semester that I took the course with Charles Isbell and Michael Lim. And then in spring 2016, I had the opportunity to TA the course. So after I finished that course, I had the opportunity to TA the course came about. And, because Professor Isbell is now the dean, he's very hands-off with his courses, and the lectures are pre-recorded. So basically, I had to somewhat run the course. I mean, I'm not going to say, completely run it, but I could basically do, for instance, every office hours, that was, it was me and another guy basically there. And, at first it was like, it was, very difficult, because some questions that students have live, you don't have a clue really. But then you feel the pressure, and then you start researching and reading and trying to answer. Says, I'm sorry, I don't know the answer to this question, but put it on the forums, and then I'm gonna go and then answer the question for you later, right? And then so the students will put it, and then you go read, look for the answer, and you have a little bit better understanding than them. Yeah. You don't have a great understanding, so you still can help, right? But you're not Rich Sutton.
Yeah.
Right. So I had to kind of go back and then read and then, answer. And then they would ask more questions and go back to the books and then read from 5 different books at a time, because that's actually very helpful. You have 2-3 different books. One is like operations research approach. The other one is like reinforcement learning approach. The other one is control theory approach. And then you can actually have a better idea what's really happening there. And then you explain that, and then you explain this and so on. And I've been doing, I did many semesters, and then I guess some student recommended me to Manning, and then they reached out to me. It's like, hey, some student of your course, whatever, said that you may be a really good candidate for teaching, because I like the, I have like a little tablet, and then I used to explain with the tablet and things like that.
Yeah.
So they gave me the opportunity. I submitted the proposal, and then we started working on it. I think the most difficult part was, that I came from a medium that is a video like this interaction, and also like a tablet that I can emphasize things, and then so I can explain, use my hands, emphasize my voice, try to do stuff to convey a message, right? And all of a sudden in the book, you have nothing.
Yeah.
You have just words, right? So you're like, how do I emphasize this word? And then a lot of times I would just like bold the word, or do italics, things like that, and then my editor was like, no, that's too horrible. Don't do that. Just, And I'm like trying to explain it the way that I explain on a live interaction.
Yeah.
And that was very cumbersome. I think that was probably the most difficult part. And then the other part I would say is, well, so, I have 2 kids, and, well, I had one when I started working, then my second was born, and that was pretty hard because, I work full time, I work part time. So full time at Lockheed, part time at Georgia Tech, and on top of that, I was writing a book. So that was extremely challenging.
Yeah.
But it was fun. I mean, I enjoy doing it. So to me, it was more like, well, I'm either gonna have fun doing this thing, or I'm gonna, have to say hi to my kid. So that was kind of the hard part. But other than that, it was fun. I mean, I think that the lesson that I learned is that oftentimes, even if you're not 100, like you're not confident that you can do it or not, once you get on the road and start working towards it, as long as you're committed to have an outcome or something out that is of quality, right? Things are going to happen in between, and you're going to get really good at it, and then you're going to be able to explain it in a good way. And I think that's actually, that's a message I would say, folks, that sometimes I guess it's called, what is it called? Like Impostor Syndrome, I think some people call it. Like, reinforcement learning, but you're like, I don't know as much as him, or I don't know I don't know as much as Rich Sutton, and I would say, like, why am I going to write a book? I mean, Rich Sutton already has one. But in your thinking, you have to say to yourself, well, my voice is different than Rich Sutton, and that's okay, right? You're not trying to replace, you're not trying to compete, outperform, or anything. You're just putting another option to folks, and then you commit to success, to do something good, right? It's success in that sense. Like, I'm gonna get a really good product out there, and just work towards it. I think that the book is really good. I would say the only thing that I wanted more of it is being able to add more stuff, such as, transfer learning, meta learning, and so on. But, it's like, okay, sure, I can, the book was already like over like 50 more pages that they asked me for. And they said, like, no more pages. You can't keep writing. Let's just publish this. So, I would say that would be my thing. I wanted more algorithms, and I spent so much time on covering the basics that then the algorithms were like a little bit too, in only like a few chapters, right? That I wanted to expand that for another 5 chapters or so. But, that's it. That's another opportunity for somebody else. You see that?
Yeah, this seems really hard, your process. I mean, the top of it, working in 2 basically different companies or the university, and with the kids, it must be very hard, and no sleep at all, I would imagine. And
but it was hard. That was a hard 3 years. Although I'm getting back into it with a PhD, I suppose. So it's gonna be something similar.
It must be addictive kind of feeling, maybe.
I think so. It's a lot of fun. It's lots of fun.
By the way, I want to ask something related to your saying. Before the before question, you said that if you want to learn something, you can read, and later you write some blog posts. So you wrote some blog posts later, then it is more usable for your book, or you don't have any blog posts. You can directly read into write your book.
No, because, well, okay. So the blog post really, or the way that I did it was internal, right? So it's I guess Piazza is what it's called, and it's like a school forum, right? So you can't grab that. Well, I mean, you can grab the information because you learn these things, right? As opposed to grab the information, with and publish some stuff is student information, right? But it teaches you. So what I learned from that, to answer, student questions, is I understand what the questions are like almost every semester now. Students have problems with, like, okay, what is model-based reinforcement learning? And some students think that, it has to do with a deep reinforcement learning model. And you're like, no, not quite. They talk about the model as the MDP. So you need to explain that. Or what is off policy versus on policy? And you have to explain these things, right? So, and then you try every semester, like, explaining, okay, this is the difference between off policy and on policy. And you try. And at one point, you not only you understand it better, but you understand how to explain it so that other folks understand it better. And I think I did that in the book a lot. Like, I actually even put a lot of like intuitive examples too, that, like I pull examples or like stories of my daughter and things like that, just to try to bring people to a like intuitive level so that they can, oh, I understand what he means by this. And then you read now the definition of, or the differences of on policy and off policy, and then you kind of more intuitively have a sense of what it is, right? Yeah. Did that answer your question?
Yes, of course. Thank you.
Okay.
In the topic of the AI and the reinforcement learning, one of the companies, I mean, you currently work is the Lockheed, and the reinforcement. I think the reinforcement learning research is actually quite impressive, and like the military science, like the defense industry. I think here is also the same. The Turkey, most of the work here is that like either the military companies or the universities basically just doing this as a like a in the beside, like, I mean, I don't see much of the other type of companies that currently trying to use this. I think it has some reasons for that. We will maybe deal with that. But what do you think like about the reinforcement learning research in the actual, like, beside the university, but as a, like your position, like a research engineer or software engineer, just would happens to be write some reinforcement learning related stuff. It could be everything, like even it could be just something to maybe maintain some of the code or do the basic operational work with the software, but still touches the RL. So what do you think about this type of like actual production stuff with the reinforcement?
I think it's a matter of working that aspect. And I would say it's many companies, not just the defense. I think in my case, defense, and I do care about that industry personally. I have to move from Venezuela, flee my country basically, like sort of a refugee because of folks really not not protecting the liberties of humans and whatnot. But before, I don't want to get into politics, of course, because lots of people think differently. But I would say that defense is it's a vital thing to work on, and sooner or later, other countries that perhaps are not necessarily pro freedom or pro individual freedoms, I mean, and more totalitarian, then they may choose to try to do something, and they don't care about AI doing harm and things like that. Some of them don't, and we need to be prepared for that. So the research in that area early on is good, and then later on more systems engineering and actually work towards it. But I would say that other companies too have that. Like I can say firsthand. I know Tesla, for instance, is hiring deep reinforcement learning folks, research engineers as well. So I think there's a lot of need right now for research engineers in that sense, even more so than research scientists, which so for folks who don't know, the research engineer would be more like a bond between this research scientist who develops algorithms and research does more like the math type of research, right? And then a software engineer who doesn't really know much about reinforcement learning but knows a lot about software, right? So having that role in there, so that you can basically adapt some of the research that you see publicly available, adapt it and tune it to your particular problems. Perhaps even iterate, and you have an opportunity to publish something, and then also develop environments, right? That you can use some of the algorithms, and then if you want to do a self-driving car, you need an environment for that self-driving car, right? So how does it look like? Engineering, for instance, the observation space of an agent. That is actually the side of the environment, but it's probably that's probably the job. Like, you need to really learn how to, come up with some observations, and what is the action space that you want to give the agent. Does it have to be high level, low level, and so on? But I think if you work on those things, I think many companies are gonna be using deep reinforcement learning for their things. Like, I know, well, self-driving cars, Tesla, Lockheed Martin for sure, and I'm sure that other companies, defense companies, and many other um, sectors, right? Industries.
Yeah.
But I think the important thing is to know that not a it's not production ready, but that doesn't mean that you cannot make it production ready, right? You just have to work towards it.
Yeah. Yeah, that's a really great answer regarding to how this tech actually applied in the real world and companies. Like you mentioned, the self-driving cars and other. Maybe I would probably should have compared to the other type of the deep learning stack. Maybe like compared to the computer vision or the NLP, I think it's a bit in the premature side, I would say, even though it's still used in some production cases. It's kind of, yeah.
So you're saying deep reinforcement learning is premature as compared to computer vision? Yes.
Yes.
Yeah, but if you think about it, so computer vision is solving one little portion of the deep reinforcement learning pipeline, right? So when you do, like, if you're doing self-driving cars and you want to track a pedestrian, a reinforcement learning agent needs to learn the entire thing. Or if you say deep reinforcement learning agent, the point is that the whole pipeline is learning that and is learning some other stuff. I actually believe that at some point there's going to have to be some trade-off, because while deep reinforcement learning, like end-to-end learning from raw inputs to outputs, is a good idea in the sense of, you're not going to put biases into the systems and so on. I think at one point we need to think about doing reinforcement learning as an intermediate or as part of the pipeline of decision making. Because if we have already so many computer vision models, right, that can track pedestrians, why would I want to just learn again end to end, right? At least, in the short term, I'd rather use that as the input to the reinforcement learning, the decision making portion of the system.
Yeah.
And then you can say, I can track that pedestrian, and now I only need to decide whether I'm going to move left or right or brake or accelerate, right? So I think the problem, it becomes much easier. And we can also have modules, right, on the entire system that we can test individually, right? You have the tracking, and you can test what is the percentage of that. You can also debug the problems of that particular system, right? And then the decision-making system could be a little bit, I know that's kind of regressing, not from reinforcement learning, but if you look at the history of artificial intelligence, we've been doing that for a very long time, right? Going into end-to-end as much as possible from raw inputs to, and then going back to kind of more classical approaches, right? Like planning and search and things like that. And then going again, learning and so on. And I think that actually is just like, it's just good for the long term, right? You just try something, then try something else, then try something else. And while you're trying different things, then you're going to actually converge to a better approach, overall system.
Yeah, that seems reasonable. And the topic, and maybe it's a follow-up question to this, it's also a bit something that you already talk about, but it's about like relating to the transfer learning and like a plug-in models that are existing for the like computer vision models or AI models, like or APIs like GPT-3 or things like this. Do you think you see a future that some RL algorithms, like you have like a planning PPO algorithm that is like deployed as an API? I don't know. I mean, it's not possible to, of course, to generalize for everything, but at least for some kind of useful use case that could be like happening. I think the issue with the RL is that it's really unpredictable. I mean, with even the papers, you see something, and if you just change the seed or something like this, that it might produce not exact results, and or even the implementation of that code in one code base is entirely producing different results. So yeah.
Yeah, that's a good point. So Whether it can be done or is it going to be done, I think so. I don't see why not. I do think that yeah, like the generality of it, right? How general is it going to be, or what for exactly, precisely? I'm not sure, but I'm sure that some companies perhaps already use it for, well, you're saying as an API. So I can see Amazon perhaps doing something like that. Amazon Web Services, they do have lots of different kind of APIs for, like, computer vision or things like that. And I think that they've been also hiring a lot of reinforcement learning folks. So they may be working on that. I don't have firsthand knowledge in that case, but they may be working in that. Um, um, and if you look at libraries such as RLib, Ray, really good, by the way. I recommend that as if you want to do like more production type of work. But if you look at that library, they even have a way for you to kind of like put an RL in production. I personally have not tried it, but I've read the documentation, and there's like, it seems like there's a way that you can put it as an API type of agent. Now, personally, I don't know which companies are going to be doing that. Maybe, like I said, maybe Amazon would do it for like recommender systems and things like that. I don't know. Maybe OpenAI does something similar to their GP3, just for the sake of fun, right? Let's do something fun, like you write a book write a couple of lines, and then out comes a long text. But because reinforcement learning is so task specific, at least nowadays, that's what it is. I'm not sure that is going. I don't know. I don't know that is the interest of folks. I don't think that many companies want to do that. I don't see that portion. Like if somebody at Tesla is working on a self-driving car, why would they release a perfect pilot API, right? So that Mercedes and BMW and everybody else can use it? No, I don't think that they're going to do that. Or why would Amazon release their API to the optimal, advertisement of products, right? So if you're interested in this eraser, I want to, advertise you this pen, right? Pencil. So, like, what is, like, that is their business, right? So I don't think that they want to put that out there as an API so that other folks use it, unless they charge a lot of money for it. And then maybe yes.
I actually saw this question pop up recently. I was a bit interested in the gaming and how the deep learning stuff is applied. And maybe if you know, one of the stuff they actually use in the production is the deep learning super scaling tech by the NVIDIA. But of course, like you mentioned, this is the same kind of stuff. They kind of want you to buy their hardware. But in terms of like to do game developers, they actually developed an API call, and they integrated this with Unreal Engine, and you can just plug some basic input-output interface, and you can just use the deep learning stuff. And I actually saw this asked by a lot of the game developers. They want to use some of the RL techniques in their characters, animation, and things like this. But I mean, with the game companies, they don't have RL researchers employed, or they don't want to pay for it, but they just want to use it somehow easily. And this is why I thought maybe it could be something that, at least for the gaming, it could be useful. And if they, I mean, like you mentioned, there's also the business model and how is it going to be handled. That's really good.
Right. And I think Amazon has done a good job at doing that. They, how does Amazon Web Service start? Basically, because they have lots of servers, and they have months where everybody's buying lots of products, and months where nobody's buying products. So they go like, okay, so how do we sell then the space of the servers, the compute power of the servers, when we're not using them? Well, let's just do that. Let's sell the compute. Okay, boom. So I can see how they are going to at some point do the same thing with including like advertisement or reinforcement learning, but it would have to be specific, I suppose, at one point. I think there was actually OpenAI tried to do something similar. They had an environment or a collection of environments called Universe, I think.
Yeah.
Back in the day, that project was abandoned. I think actually Kaparthi and Andre Kaparthi
Yeah.
was leading that project, and then abandoned, and then they didn't work on it anymore. And that was actually an attempt to artificial general intelligence, and then sort of like a super smart API, whatnot. I think that I think that was the attempt. I never talked to them or anything like that. But I think so while it's a good idea, I don't think that companies, at least for-profit companies, currently wanna use the time of their engineers of their workforce to create an API for others to use, when we are currently working on creating AIs that solve specific problems to that company, right?
Yeah.
So I think the API usually comes as a later type of thing, even though that you say NVIDIA has this product. I can see that as a classification type of product. You have some, because on images, you want to recognize anything in your picture, then that's a lot easier than what task do you want to solve. There's so many tasks that you can solve, right?
Yeah, exactly. Yeah, exactly. That was my also thinking. And regarding to the bit of like the technical side of the developments, I would say I have two questions here regarding to one. First is regarding to multi-agent systems. They seem to be like the hot topic, I would say, in the few recent years, but they are still very hard to train, and I mean much harder because you actually train multiple agents at the same time, and you also have to declare how are you going to train them. Are they going to act as one, or they will train separate agents and things like this? But even with all the tricks, they don't seem to actually sometimes not even be useful, because some of the already existing algorithms regarding to optimization or the swarm intelligence algorithms, they seem to sometimes outperform them, or they don't seem to like worth trying. Maybe I don't know how to put it best, but what do you think like about the future of the multi-agent systems in general?
I think it's very important. I think I'm just gonna get started on my PhD in the fall, but I think that's gonna be the direction of my research. I think that if you don't nail down the multi-agent aspect, it's just not it's not good enough. You're not going to really take all of the things into account. I think that current reinforcement learning agents, if you train them in a basic way, and some types of agents more than others, but in general, we can say that reinforcement learning agents depend on the environment being stationary.
Yeah.
Right. And what that means is that everything needs to stay the same. Right. Which makes sense. Right. If you're like, let's say that you're learning to play piano, right? When you're at the very most like basic skill level, you want to put some background music to play along that is always the same, right?
Yeah.
So you put a recording basically to play against that recording, and then that's how you learn. Imagine that you have 5 friends that you want them all to learn music at the same time. It will be a mess, a disaster, right? Not good at all. Now, if you have a skill level, really, really high skill level, yes, you can learn to, play a song together and so on. So there's some work in there that needs to be done. Currently, what kind of like the more standard way to training these agents is actually to freeze some of the other agents so they don't learn. So there's no change on them. Yeah. And then you improve one at a time and then improve the other and so on, right? So that's where the self-play training mechanism comes from, right? Or, I guess you have curriculum learning, self-play being part of that. You have, a version of yourself. You're playing against a version of yourself that is static, but you are learning, right? And then you do it again and do it again and do it again, and you basically play against someone around your level or multiple players that are around your level, but they don't train. You train, right? And then so that helps you get better and better and better, right? And then you have obviously the league play and things like that, which are if you only play against yourself, you may develop some strategies that don't work well against the population, the general population. You want an agent that is strong enough that works well for everybody, against everybody, right? But But this is an adversarial type of training. But what about collaboration, right? And what about teams competing, right? So you have adversaries, but teams of adversaries, and not just 2 sides, but 4 sides, 5 sides, and so on. So I think that game theory in that case is going to play a big role because of the complexity of the interactions of the different interests. But definitely multi-agent reinforcement learning, and folks can still call it, I've seen it, deep multi-agent reinforcement learning or whatever. I think there's one researcher that is worth mentioning in this case, Jacob Forster. And if folks can look in, he actually graduated not too long ago, probably 2 years ago or so. So his thesis, it's probably 150 pages or so, but it's worth reading for those who care about multi-agent reinforcement learning. And that's definitely another book that somebody can write, and let me know when you write it.
I hope one of our followers see this and try to get inspiration. And regarding to other technical maybe thing that is like popped up in recent years to more degree is, I would say, the batch or offline reinforcement learning. I think this is a really old way of doing batch. I think batch RL is very old actually, but recent years it tried to revived again, and it came back from the dead. And I think because with the real world systems, it kind of is really data hungry, and this type of the training a supervised learning problem and collecting some real quality data and from different sources. And what do you think about the offline reinforcement learning? Do you think that we could in some time maybe share our data sets computer vision data sets? And
I think Berkeley is actually doing a good job at that. I would say Berkeley, Sergey Levin, he has also, I think, a tutorial on YouTube on offline, I guess some people call it offline batch reinforcement learning. And I think the argument is, the real world, systems, you can't possibly be, training for hours and so on. First of all, it's real time, so that's a big problem. So what is the best way to extract information from this batch of data? And I think what you're saying is a good point, that it comes back from the death, because I believe that almost everything comes back from the death in some way, because I think that the ideas are good, but then a lot of people start focusing on this idea and then that idea and then that idea and so on. But as we move around, it's not that we're going backward. It's not that we're doing something bad because we're looking at something that happened in the past. It's actually now, with the things that we currently know, our current state of knowledge, how can we make this batch learning better? And I think it's a really good idea to also look into that, because because of the real world systems, right? And if we want to put reinforcement learning into real world systems, we're going to have to answer many things. So also something that we haven't mentioned, but safety would be another thing, right? How do we put constraints into these agents? Exploration is a good idea, but how good do you want me to explore, right? Do you want me to fly an aircraft in a little reckless way, or do you want me to fly it in a way that is expected by a human, and so on? And so I think those batch learning, so extracting the most information from offline data, that's a good one. And then safety and constrained agents, that's another interesting point. And obviously, we just mentioned it, multi-agent system, which is sure. I mean, you can assume that the world is stationary, but that's a lie, and we all know that is a lie. So we are changing. We are all humans, and even animals are changing strategies. I mean, that's what evolution is all about, right? We change strategies constantly and get better and better and better at things, and that's how we improve and get better. So if we want these systems to actually be part of that cycle to some extent, right? I want the AI to go and bring me some food or whatever, farm, go to take care of the farms and then produce food for the rest of the world. Then you need to make sure that the evolution, even plants evolve, right? So you need to make sure that these things continue to learn and continue to get better know or are aware to some extent. I don't, probably that's not the right word, but at least that there is some, we take into account that we are multi-agent.
Yeah.
We, as in, this world.
Yeah, exactly. I think I have one question left for today, and that's a really brief question, or maybe wide question, I would say. Is regarding to areas of the areas that RL could be applied. I think we already mentioned robotics and this self-driving cars, and the gaming is of course already existing. But I think there's also some other type of stuff like the finance, or maybe the grid optimization, energy systems, and I saw some work regarding to maybe also web browser testing or things like this. I mean, can you tell about a little bit about like what could be like the areas that is not like hyped or researched that many as other type of the like autonomous systems that already there's, yeah.
That's a really good question. So I would say, to me, is one of the things that I like my students in the reinforcement learning course to get by the end of the semester, which is, it's kind of amazing, but any decision-making problem can be represented as a reinforcement learning problem. That is the power of reinforcement learning. Anything. Yeah. Do you want to learn on when to, type some words? Then, you can represent that. I'm not saying that that's a great idea. Yeah. That's probably a dumb idea, but it's okay, right? So anything really that has decisions, which is basically almost everything, can be represented as a reinforcement learning problem. And sometimes it's really good to, that's why I spend so much time on Markov decision processes in my book, right? And I think that, the idea, so Markov decision processes being a mathematical framework, a tool to think about problems as think about decision-making problems as problems that you can, represent in a way so that reinforcement learning problems can interact with it. I think that idea or that knowledge is should not be overlooked, because a lot of people immediately go like, oh, PPO, oh, rainbow, oh, there's some other new algorithm there, and then start looking at these things, but don't spend too much time on the Markov decision processes. Actually, there's so many. I don't even know all of them. It's like POM-DP, MDP, DEC POM-DP, DEC DP. I mean, just like so many. But the idea is there basically that you can represent any decision-making problem in a way that some system can solve it. And by that I mean a computer system, right? It probably has more background, right? But that's relevant to reinforcement learning. That's what matters, right? Yeah. So I would say folks should spend time thinking about Markov decision processes, and a lot of time, and then practice that in your head, right? Okay, you mentioned the financial systems, right? Yeah. That's a really good point, right? So how would you actually implement that? Another thing that I recommend is, there's actually very interesting, but there are a lot of environments that do this kind of thing already, right? So if you like look up, for instance, stock trading OpenAI Gym, always put OpenAI Gym to whatever problem you want to solve. Yeah. And I can bet you that there's somebody tries something, but I'm not saying that you should not do it because somebody else already tried it. I'm saying go and draw inspiration from that solution and then try to solve it to your particular problem in the way you think is best. Because, you may think that, perhaps the stock market trading agent should know, in this sense, the observation should know about, the current price, the old price, and so on. But maybe some other person has an idea that it shouldn't be just that. It should be that plus, what is the political state of the world, right? Are we going to go to war or not? Yeah. Right. So, or, it'll be this and this and that and so on. So you have the capability to creating a system that is perhaps even better than the ones out there. And I think that is, that's an interesting thing to look at. So I would say, so in terms of what can reinforcement learning be applied to, I would say everything. Yeah. And it's just a matter of you either implementing an environment that helps you do that, you can have always a backend, an API that goes out to your bank. Actually, some banks actually have an API. I think I don't want to do like advertisement, but even for stock trading systems, there are banks out there that just receive API calls. All of a sudden, you can implement an OpenAI Gym interface and put a PPO agent, and they also have like a testing system. So the API, you pass a switch and you don't use real money, you use fake money. And then all of a sudden now you can be training the agent for many hours, right? And then you have, I'm not giving ideas that folks should not implement a financial agent, or don't make me responsible. Unless you make a lot of money, then call me and then give me some. But other than that, no. No, I'm just kidding. But yeah, no, it's a any problem basically. For the most part, if it's well represented. And of course, I wouldn't say any problem meaning like, oh, you want to solve all problems at once. That's not what I mean. I mean like any specific problem that you can clean and represent as a single task, as long as you can think of it as a decision-making problem, and MDPs and all of that family of things teach you or help you on how to think. I think as long as you learn a little bit about that, you can think of any problem as a problem that can be solved by a reinforcement learning agent.
Yeah, that seems really helpful. I think because we get this question a lot, like, can I do this with RL? Can I do this with RL? Or should I do this with RL? Maybe sometimes they ask this. And that seems like, I think, a bit clear answer to folks who kind of wonder about this stuff. And I think that kind of gets end of our questions. And we want to thank you for your time. It was very helpful, and from your perspective, how you started to RL, how your career moved on. I think it will inspire a lot of people who are in the same kind of field, or both, I would say. Like, they are working on some stuff, but yeah, there's always opportunities like the online master course or something else. I mean, there's always a way to, I think, get better if you want, if you have passion. And if you want, if you had last words about that's it.
No, thank you both. I mean, for this discussion, I really enjoyed it. To be honest, it was a very, very nice questions. You guys obviously spent time thinking about this question, so thank you for that. And to the audience, like I said many times during the conversation, it's a matter of getting started and doing things as opposed to sitting and waiting. Just do something, and it's okay to fail. It's okay to look not so good. Don't worry about it. Just put yourself out there, and then little by little keep doing it. And then little by little you get some you get to be part of the entire community, which I think is it's a wonderful community, reinforcement learning, that is. So, and other than that, thank you.
Thank you for your time.
Thank you.
Yeah.
And also, I took some your suggestion, and also I would say one of first of them, because you said a lot of sentences about it, but the first for your suggestion is for the beginners are really important for me, because I am a senior student, so these are really important for me, and thank you for this.
Yeah, absolutely. I look forward. If you have something, let me know. I look forward to it. I think it's that's mostly the barrier that a lot of folks need to break, is to just try. It doesn't matter if you don't look good. If you look good, it doesn't really matter. Just try. Always put good heart to things, but that's a recommendation for life, right? Okay. In general. But as long as you do that, I think it's the learning is in the walk, right? The learning is not at the end of some magical event, then I learn. The learning is the process, the walking, right? So a lot of folks don't want to start the walk because they don't have the learning. And it works the other way. You have to start the walk so that you can actually get the learning. So yeah, absolutely. And always share something if you guys have something.
Yeah, and maybe as a quick notice, one of our videos had a comment, one of our viewers, I would say, that he wrote that he actually trained some finance agents and he made himself rich I mean, that's what he wrote actually.
That's good. Give me some money then.
Yeah, I think
if you use my book, I charge half.
Yeah.
Half the earnings. Not kidding.
Yeah, he actually talk about this, and he was in vacation. He had made enough money to his life. I think that was what he wrote. Yeah.
That's good.
Yeah, I don't know it was true or troll comment or something like this, but yeah. And yeah. And thank you for your time again. This was very helpful. I think it was very fun to talk about you. And yeah, I think we can just finish it here.
Absolutely. Thank you, Gurkan and Ramesa. Ramesa.
Yes.
Oh, sorry about that.
No.
Ramesa. Thank you both.
But bye-bye.
You're welcome. And have a good
Bye.
time.
You too. Bye.
Goodbye. Of çok yoruldum. Aman tanrım.
Sıkmazsa mıydım? Bittin mi?
Ya çok zor bu iş yapmak ya. Ben o yüzden başkaları işte gelsin istiyorum ama kimse yapmak istemiyor.